Dams are one of the ways we control and engineer nature. We use them to store staggering amounts of water, control flooding, and generate electricity. This is the world's largest hydropower dam, the Three Gorges Dam in China. When it was built, it flooded a total area of more than 156,000 acres of land with 42 billion tons of water. The sheer amount of water was enough to alter the Earth's rotation by an estimated 0.06 microseconds. So in spite of their extraordinary size and capacity, how are dams built? Dams are usually built between a water source such as a river and a valley. The valley is later converted into a reservoir or an artificial lake using either water redirected from its natural source or elsewhere. Rivers are diverted using tunnels along the side of the dam or its foundations. During the construction of these channels, soil is excavated and larger rocks are blasted with explosives to clear the path for water. For dams built across large flowing rivers, simply constructing channels to divert the water supply won't be enough. Instead, dams hoping to divert large rivers utilize dry construction pits built on one side of the river. The dam construction then proceeds in stages, where water is allowed to pass through openings in completed portions of the dam. The reservoir can then be filled. Dams are either built on soil or rock foundations, depending on the type of dam and how much water it is intended to support. The foundation must be rigid and strong enough to support both the weight of the dam itself and withstand the water pressure exerted on it. Since foundations are built below the ground, pockets of soft soil or rock are sometimes found during construction. They're replaced right away with stronger materials to ensure the dam's foundations are as sturdy as possible. Then any fissures or cracks are filled up right away with grout to prevent water from leaking out once the dam is complete. Going on to building the dam itself, you might be wondering where all the concrete comes from. For most dam construction projects, concrete batching plants are built on site. This gives workers access to large quantities of ready-to-use concrete, which is transported to the construction site using either a system of conveyor belts or via trucks and cranes. This concrete is then poured into a mold made in the required shape of the dam. The mold is built up in layers, 3 to 6 feet high. After the dam is built, its reservoir can then be properly filled up. It can take several years for the process to happen either naturally or with the help of pumping units. At this point, the water level behind the dam must not be at operational levels. The dam has to be tested first. Once construction is complete, engineers use the first filling as an opportunity to test the dam and see if it will hold. They closely monitor the filling to look for any deficiencies in the dam's design or construction and safely address them. Inspectors check for signs of seepage, cracking, or erosion. Repairs can be made to get the dam performing to its intended capacity. Dams are split into 2 categories, low hazard and high hazard. This refers to the amount of damage it would inflict on its immediate surroundings if the dam fails. Dams also feature components specifically designed for safety, such as emergency spillways. During extreme events, including excessive rainfall or snowmelt, massive volumes of water spill through and are diverted downstream in a controlled flow, ensuring the main dam structure does not need to withstand the additional water pressure. Dams need to stand the test of time, so they're never truly finished. Changing water levels around the world affect the operational conditions of these megastructures over time. Prolonged droughts can significantly reduce water levels in the reservoir behind a dam, affecting its ability to provide electricity. Whatever the case, dam operators and planners need to be ready to adapt and respond to any condition.